Good morning everyone, Jai Hind. In the second series of my lecture, today I will be covering the most important topic, that is PERT and CPM. It is one of the, you can say, interesting topic in whole OR, since it is being used by many managers while they are actually handling a project. So it is an essential set of, you can say, method that every engineer should know while going for an industry job. So, starting with my next lecture. Yes, PERT and CPM actually it stands for Project Evaluation Review Technique and Critical Path Method. Today I will be covering this CPM method, that is uh, uh, critical path method. What is a project? First of all, we should understand that project is actually a combination of interrelated activities. Project has a definite, you can say, beginning and end points. It is a whole project is broken down into different set of entities, so that we can find out what is the actual duration of each and every event. So in this way we will solve this whole problem. The project can be divided into three parts. Number one is project planning, number two is project scheduling, and number third is your project controlling. Our ones come into the project controlling part. In project planning, we actually set plans and strategies, how to execute a plan. All the, you can say, uh, planning is done in this phase, like what kind of manpower is required, how much time is required, equipment is required, resources is required. So these are all the financial constraints available with us. This comes into the project planning. Second one is the project scheduling. In project scheduling, what actually we do, we find out the start and end time of each activity or the event. We find out the critical activities out of it, and in controlling part, we control the whole process. Like if there is a critical activity in every part, you can say both scheduling and controlling, we will solve it. So in controlling, we know what is the critical path, which activity is more critical, which can take more time. So we have to concentrate our whole energy and resources so that our project is not delayed. If our project is delayed, then we have to give a reply to our customers why it is being late. Since time is money in you can say industrial scenario, so time is like a very important thing. If you have given a due date for a project, you have to complete it on or before that due date. After that, you will lose all the connection with your customers. So it is very necessary to have a correct planning, scheduling and controlling of a new project. So regarding this, this was a little bit of an idea what is a project planning, scheduling and controlling. Now I will get to these two parts, that is CPM and PERT. As I told you, CPM is critical path method. It is a deterministic model. Here what we do, and this is probabilistic model. Deterministic and probabilistic. In CPM, we take the, you can say, data from the background, like from history, which activity is can be done in how much time. That kind of model, we have a determined time for each activity, determined time. But in case of PERT, that is program evaluation and review technique, we have three types of time. That is, number one is time that is pessimistic time. optimistic time, most likely time. Pessimistic time is the time which an activity can take when everything goes wrong. That is the maximum time a project or an activity should take. Optimistic time is the time when everything is good, no breakdown, nothing short of resources, and no problem in an activity. Minimum time. That is the minimum time. That is the maximum time. That's why it is pessimistic. This is the minimum time. Most likely time is actually a standard time. It is in between the pessimistic and optimistic time. So you can see here in CPM we take historical data, we take a reference from all the activities which have done before. We have a timeline for each and every activity in it, and we have only one kind of time, that is a deterministic time. And in PERT we have a three types of time, like pessimistic, optimistic and most likely. Today I will be covering critical path method. Before doing critical path method, there are some I will tell you with the problem only. Let me draw a project in the like for example, there is a project whose activity and duration is given to us. First thing is we have to make since it is a graphical method, so we have to make a network of series of event in a synchronized manner. After that, this is a network, this is called network. After that, we will find out the critical path in this network. Like for example, I will take an example, like this is activity, this is duration. Activity is actually, I will tell you what is activity, like 1 and 2, 1, 3, 2, 3, 2, 5, 3, 4, 3, 6, 4, 5, 4, 6, and 5, 6, 6, 7. Now, what is activity? Activity is actually a time between two events. Like an event is donated by a node, and this is two event, and they are represented, they are connected by an arrowhead which only flows from left to right. Now, we will make this whole network. Let me make it smaller one. These are events and they are connected by arrows, and these arrow can flow only from left to right. Let's now make this network. Duration for each and every activity is given, that is 15, 15, 3, sorry. Yes, these are the duration in which each and activity can be conducted. Like 1, 2 activity can be conducted in 15 seconds or 15 minutes or 15 hours, 15 weeks, depending upon duration can be, this is the time which it will take. Now, look here, Now we will make network for these activities like 1 and 2, and then there will be 1, 3. Now 2, 3. Okay. Next is 2, 5, 3, 4, 3, 3, 6, 4, 5, and 4, 6, and 5, 6, and 6, 7. In this way, whole network is created. After that, we will write down all the duration which are associated with each and every activity. Like for 1 and 2, it is 15. 1 and 3 is 15. 2 and 3 is 3. 2 and 5 is 5. 3 and 4, 8. 3, 6. 3 and 6 is 12. 4, 5 is, sorry, it is 4, 5. Wrong. I have made wrong arrow. Okay. 4, 5, it is 1, and 5, 4, 6 is 14. 5, 6 is 3 and 14. Okay. So this whole network is created. Now what we have to find out? We have to find out 4 kind of time from this network. One is, I will write down. First we will concentrate on E and L. This is the earliest time, and this is the latest time. In earliest time is the time at which the activity can be started, maximum, earliest started, and the latest time is the maximum time in which it can be completed. So we have to find out for each you can say event, earliest and latest time. Starting from this node, here E is 0. Now after 1 it comes to, so we will find out when 2 will be starting, that will be 0 plus 15. So it is 15. Now 2 and 3, you can see there are 2 nodes coming to 3. So we have to choose between these 2 times. The 2 value of time will be 0 plus 5, 15, and 15 plus 3, 18. So we will take the maximum time, 18. Okay. Now we will go to 4. E is equal to 18 plus 18, 26. Now we will go to 5. Now same here, 2 nodes are coming. We will take the maximum value, 26 plus 1, 27, and 15 plus 5, 20. So we have a 27 value. Now at 6, there are 3 nodes coming. That will be 18 plus 12 is 30, 26 plus 14 is 40, 27 plus 3 is 30. Maximum is 40. Similarly, E is equal to 54. This is known as forward pass method. In forward pass method, where there are 2 nodes meeting at a point, we will have the value which is maximum. Now with the help of backward pass method, we will find out the latest time. So it is a maximum time. We will, L is equal to 54 over here. Now we will subtract the duration from each and every activity. Here you can see L is equal to 54 minus 14, 40. Now we will come to 5. L is equal to 40 minus 3, 37. Now we will go to 4. Here you can see there are two converging. It's diverging actually. So there are two arrows diverging. So this will be 37 minus 1, that will be 36, and 40 minus 40, that will be 26. So in backward pass method we will take the minimum time. In forward pass method we will take the maximum time. We have come so far to 4. Now L is equal to, similarly there are two diverging arrows over here. 26 minus 8 is 16, 40 minus 12 is, that is 22. We have to take the minimum time. Okay. Now we will come to 2. Here 18 minus 2 is 15, and similarly 18, 2 diverging arrows. 15 minus 3 is 3, 18 minus 15 is 3, and 15 minus 15 is 0. And in case of L we have to take the minimum time. Okay. So we have find out all the values of E and L over here. So one of the shortest cut for finding out the critical path is where the value of E and L is same. That means there is no extra time in that. So these are our critical paths. Here you can say, I will take a different color. Here you can see this same E and L value, this same E and L value. Sorry, you can come here, 2, 3, 1, 3, same E and L. This is this and this and this. So 1, 3, 1, 2, 3. Actually, you can say this 1, 2, 3. ये नहीं आएगा. 1, 2, 3, 4, 6, 7 is our critical path. 1, 2, 3, 4, 6, 7 is our critical path. That means the activities which are in these paths are concerned, are our concern. These are our critical activities. So we have to take upon these critical activities very seriously, so that there is no lagging in the project. Now we have find out the 2 times in it. I have told you we have to find out 4 times in it. It is one of the shortest method to find out the value of you can say critical path. But there is a proper method, that is a method of using float. And what is a float? Float is the extra time between the E and N in each activity, where we can compensate. Like you have you know that in the head of activity there is 10 minutes extra. So we can compensate in between these activities so that the project cannot be delayed. Okay. Now I will find out these two parts. 2 more times. One is the our latest start time, that is TLS, and the other is the earliest finish time, that is TEF. These 2 times we have to find out. TLS is the latest start, kitni late se late we can start, and TEF is the earliest finish time, how much early we can finish our activity. Now I will again draw this in a tabular form. This is my tabular form like this. I will again activity, duration, start, finish. In start we have E and T. LS. In finish we have T, earliest finish, and L. These 4 times you have to find out. Like for TEF, we have a formula for it. TEF and TLS. That is equal to TEF is equal to E plus TIJ. E plus TIJ and L minus TIJ. These are the formula for these two time. Now I will be writing down all the duration. 1 2 1 3 2 3 1 3 2 3 2 5 3 4 3 6 4 5 4 6 5 6 6 7. Duration is 15 15 3 5 15 15 3 5 8 12 1 14 3 14. Okay. Now we have to find out the value of E and L for each activity. This is the point over here. So E will be the time at the starting point. Like on 1, what was E? Like on 1, what was E? You can see what was the value of E on 1? That was 0. So here 0 and 0. And L will be the latest time at 2. What is the latest time at 2? 15. Okay. And what is the latest time at 3? 18. So this one will be the E, and E is the earliest time of that activity, and the latest time of activity will be the L value at the corresponding event. So we have this value, we can find out. Now value of TLS and TEF. Here TLS is equal to L minus TIJ. This is also known as TIJ. So what is L over here? L is 15 minus 15. So TLS will be 0. What will be value of TEF? That will be 0 plus TIJ, 15. Similarly, TLS will be 18 minus 15, 3, and E plus TIJ, 15. In this way, we can find out whole values of E, TLS, TEF and L. I will write down all the values, that is 15, 15, 18, 18. Let me erase this. This is nothing actually. This is the value of L. Now, we will find out the value of float. Similarly, you can do all these things. Similarly, you can find out the values of corresponding activity and the corresponding 4 time between them. Now, what is important, I told you, we have to find out the critical path out of it. How we can find out? We have to find out float. What is float? Float is the extra time which is given ahead in the activities where it can be compensated. It is the difference between, what is float? It is the difference between the maximum time available and the to perform a task and the activity. So the formula is total float is L minus E minus Tij. So total float will for this activity will be L minus E, that is sorry 15 Okay, L is, yes, 15. So that will be 15 minus E is 0 minus Tij. So total float is 0 over here. Similarly for this, 18 minus 0 minus 15, 3 total float. Similarly, 18 minus 15 minus 3, 0. Here you can see when the total float is 0 for a particular activity, like in this case the total float is 0 for activity 1 and 2 and total float is 0 for activity 2 and 3. Okay, so I have given you, like in the previous, what was our critical path? It was 1, 2, 3. After that 4, 5, 6, 7. Now you can see where the total float is 0, then that activity is a critical activity, 1, 2 and 2, 3. So 1, 2, 3. Similarly, we can find out the other activities. In this way, we can find out the critical path in whole project. I hope you would have understood the this problem. The next session will be for PERT, that is a probabilistic model. In case of any queries, you can contact me personally or you can mail me at kaur@akgec.ac.in. Thank you very much. Jai Hind.